Hello everyone. So let us go ahead and look at a concept of compound angles. So what is a compound angle? Or what are compound angles? Well, it's exactly as you read it. Compound angles, two angles. So, for instance, this would be a compound angle because there are two angles here, as opposed to just having this is not a compound angle because this angle is by itself. It's a single angle, right? So, what are the use of compound angles? How are we going to use them exactly? Why do we want to know about them? Let us go back to our infamous cost diagram. I want you to notice something. So we know that in this quadrant, we've been in all of these quadrants, we've been having these general forms. 180 minus for the sine quadrant, 180 plus for the tan, 360 minus for the cos, and 360 plus for the O, right? So as you can see, these angles, you would say that they are compound angles as well because it's two angles, right? So for instance, let's say sine 180 degrees minus a particular angle. We know that the easiest way to solve it is by reduction, meaning that we get rid of the 180 minus and we're only left with this angle. So this would be sine angle, right? So yes, in as much as these are compound angles, but they're also easy to solve by reduction, knowing that, okay, this 180 minus is in the sine quadrant, it remains positive because it's sine and it's in the sine quadrant, right? So yes, this is the easiest way to go ahead and solve this when you have 180 minus, 180 plus, 360 minus, and 360 plus. And they are compound angles again because it's two angles. So what if we have a situation where now it's not a 180 minus, 180 plus, 360 minus, and 360 plus. For instance, it's sine 60 degrees plus 45 degrees. What then? Because we can see that 60 plus, it's neither of these. 60 plus is not, and the 60 plus, it's neither of these forms. So how are we going to solve this? I mean, I'm pretty sure you can just look at it and just say, we just add the angles 60 degrees plus 45. It's going to be 105 degrees, right? And then we can go ahead and say sine 180 degrees minus 75 degrees. Because 180 minus 75, it's going to be 105. And then you're going to end up with this form over here. Then you're simply just going to say sine 75 degrees. Well, yes, this is technically correct, but this is not something you want to do, right? Because now the question will say they want you to simplify this. They want you to give a numerical value of this without using a calculator. So obviously in the case where we ended up with sine 75 degrees, how are you going to evaluate this without a calculator? Because this is not a special angle, right? But wait. On these special angles, we know that special angles are 0, 30, 45, 60, and 90 degrees, right? They are special angles indeed. But because it's in this form, how are we going to simplify it? How are we going to evaluate it? We cannot simply say sine 60 plus 45 degrees is sine 60 degrees plus sine 45 degrees. No, that is not how it works. You essentially just multiplying the ratio and Completely wrong. No, never do that again. Never do that. Please do not do that when it comes to trig ratios. Because this is one thing in as much as it's one angle in as much as there are two angles. They are just separated somehow. So again, how we're going to evaluate this? There are certain formulas that you can use to solve this, to solve these sort of compound angles in which you kind of want to break down so that you can simplify your answer without using a calculator, right? So let us go and look at those formulas and what they are. You can go ahead and erase this. So we have this set of formulas. By the way, these formulas are always going to be given to you in a formula sheet, but when it comes to formulas, it's in your best interest to try to memorize them or at least understand them. By understanding them, that's going to be the best way to memorize them, right? So these are the compound angle formulas. As you can see in all of these ratios, cos, cosine, sine, these angles there are two different angles. And in order to break them down, you're going to write them in these forms over here. So in that example that I just wrote down, I don't know why I erased it, of 60 degrees plus 45 degrees, you just have to see, okay, which form does this expression relate to, right? And if we look carefully, this angle over here, it's this angle over there, and this angle over here, it's this angle over there, and they are both sine, and it's positive. There is a negative version as well. The signs are important as well, but this version is positive, and here we can see that it is positive. So we are going to use this form over here. So sine 60 degrees plus 45 degrees, we are going to replace with this form over here, which is going to be sine. Let us use the highlighters again. Okay, I'm pretty sure you don't need highlighters, but hey, we need to write them exactly in this form. That is very important. So sine A, this A over here is this A over there. It's the yellow. Yes, let's work with the colors. This sine yellow, for us it's 60 degrees. Cos, this purple angle over here, it's our purple angle over here, cos 45 degrees plus cos of 60 degree, the angle is our 60, right? And sine 45 degree. Cool. So now that we have gotten them in this form, it is going to be much easier to simplify them, because now we are working with special angles, and you must know special angles. These are angles in which you don't really need to use a calculator, or at least you need to show, right? So sine 60, we know that it's square root 3 over 2, and then cos 45 is square root 2 over 2 plus cos 60 is 1 over 2, and sine 45 is square root 2 over 2. And now there you go. You can easily simplify them. Square root of 6 over 4, if you multiply them, square root of 2 over 4, and then it's going to be square root 6 plus square root 2 over 4, because you added these common denominator. That is how you can use compound angles to simplify a trigonometric expression numerically, leaving it in its simplest form, in a fraction form. Whereas with this, which is essentially the same as this, right? You really cannot express it like this without using a calculator, because we are the special angles over here, and the 75 is not a special angle. In as much as if you type this in a calculator, it is going to give you exactly square root 6 plus square root 2 over 4. But you need to show how you got there, and that is what compound angles are used for, showing how you got to your answer, right? And I hope that that was a clear introduction on compound angles and why we want to use them in certain situations. We will be looking at examples exploring this idea. Thank you.